Okay, so in this video, we're going to take a look at some more advanced list operations. And in this video, we're going to only look at remove after, but in the upcoming video, we're going to also look at insert after. And both of these are based on using an iterator to help pinpoint a place in the list where we want to make a change, either removing something or inserting something. So remove after, the idea is that we want to remove the node that comes after the iterator. So, an iterator has a pointer to a specific node in our list, and then we'll say, okay, remove the thing that comes right after it. Now, why after? Why are we setting the function up that way? Well, it's because we can't easily remove the node it's pointing to, right? We could say remove this node. That would make intuitive sense, right? Remove this node if we had a pointer to a given node. But that doesn't easily work in a singly linked list, because in order to remove something, you always have to get the pointer that's before it, so you can disconnect it from the list. And that gets complicated because you'd have to go back to the beginning of the list and traverse forward to find the previous next pointer so that you can then change it. And that just is kind of cumbersome. And it's just simpler to have this idea of removing what comes next, right? If I have a pointer, if I have a node and I have its next pointer, I can easily redirect its next pointer around the node that comes after it. And so to just keep it simple and for a singly linked list case, we use this remove after. However, there is one little corner case here that we need to worry about. And it's that, how do we remove the head, because nothing comes before the head? You can't say remove after and refer to the head because there's nothing the head comes after. Well, fortunately, this is a nice, this is easy to handle with a special rule. We can just say, since head is the only node that has nothing before it, if we pass in a null pointer, a null iterator into remove after, then that means remove the head. Okay, so that means we can remove anything in the list, because any node other than the head, we can always find a node before it. And then the head, we just use null to mean we want to remove that one. Okay, so there are three key cases for remove after. We might want to remove the last node in the list. If we do that, then that means we need to update the tail pointer. We might want to remove a node in the middle of the list. Well, I'll call this the easy case. And then we might want to remove the head. And this requires updating the head and possibly updating the tail too, if in fact the only thing in the list is a single node, in which case the head and tail are the same. And so when we remove it, we need to update both of them. So let's go through a few examples of how remove after works. And when I show you a picture of a list and with an iterator pointing into it, I'm just going to show that iterator as a black box. And that's because it is an object. And there is a pointer field in that object pointing to a list node. And so I'm going to draw that black box to remind you this is an object with a pointer in it. But just to keep my drawing uncluttered, I'm just going to draw that box and then label it clearly as an iterator using like IT or I, so that you know that that's what I'm referring to. So let's say I start with a list that contains milk, eggs, and bread. And then my iterator is pointing at eggs. So if I call remove after with that iterator as an argument, what it should do is remove the bread. And so now we need to think through, how do I modify this list to achieve that removal and to delete the bread object? And so it's pretty clear that I need to change the next pointer and I need to change the tail pointer, because when I get rid of this node, there shouldn't be anything else pointing to it. And so these two arrows coming in are the two arrows I need to fix. So let's fix the next pointer first. I want the next pointer to point around it to whatever comes after. And so I can say temp next equals remove next. So get the next field that the temp is pointing to. Temp is pointing to the same thing the iterator is pointing to here. And so temp next will point at whatever comes after remove. So temp next equals remove next. In this case, it's null. And so that means eggs is now the tail of the list. And since eggs is the tail of the list, I can evaluate if that's the case by asking if tail is equal to remove, right? Was my tail pointer previously pointing at the thing I'm about to delete? And if it was, that means that now eggs is the tail of the list. And I need to set tail to point to this temporary. Now, if there was an object over here, this would be false and I wouldn't change tail, right? That would be the case of it being in the middle of a list. Okay, but here for this list, tail does need to get updated to point to temp. Okay, now that I've done that, my list is fine again. There's no arrow pointing to remove. Tail is pointing to eggs. The next of eggs is pointing to null. There's nothing else to do. This list is in good shape. The only remaining thing I need to do is delete this object. And so I use delete remove to take care of that. This exact same code as I described, it would work for the middle case of deleting from the middle because this next field would just get updated to point to a later object, and we wouldn't update the tail in that case. Okay, so there's one other case within we need to support, and within it there are two special cases. Okay, so what if the iterator is null? The iterator is not pointing to anything in the list. That means I want to remove the head of the list, so I'm going to remove milk. And when I'm done, my head should just be pointing straight to eggs, and I should have deleted milk. Okay, so how do I get head to point directly past milk? Well, I can say head equals head next. And that's going to update head to point to whatever the next field is of the node it's currently pointing to. It's basically my standard traversal code, right? Head equals head next. So that moves head down, and now my head pointer is redirected. And you'll see that after I do that, there's nothing else pointing at this object we want to remove. And so at that point, I can delete it. There is one other special case though that I need to embed in here. If head is now null, if after doing this head is null, then that means that there's nothing else remaining in the list, and we should set tail equal to null also. So we do need to add that extra condition. If head becomes null, we need to set tail to null. Okay, but then at that point we're done, and we've successfully, and after we delete milk, right, delete this node that head was pointing to before. And you know, I create this remove pointer so that when I advance head to be head next, I still have access to the old head, right, and I can delete it. Okay, so this code looks like this. You can find you know, an explanation of this pseudocode and a lot of detail in the Xi book and chapter 5.4. I encourage you to read that. And so I'm going to go through this kind of quickly since we already talked about the basic steps. And I'm just going to highlight the key points. So in this removeAfter implementation, I'm a little bit defensive. I first check if the list is empty. And if the list is empty, there's nothing I could possibly remove. And I just immediately return. Else, if the node inside the iterator is a null pointer, then basically I'm removing the head. And so I'm going to create a temporary pointer and set it equal to head. That'll allow me to delete it later. I advance head to point to the thing that comes after it. If the head is null, I set tail equal to null because that means there's nothing in the list anymore. And then I delete remove. So that's our special case of removing the head and making sure the tail and head remain consistent for an empty list. Whoops. Okay, else the normal case, deleting in the middle or deleting at the tail. So the first thing I do is I get a temporary pointer to the node that's before the one I'm going to remove, right? This is what the iterator is pointing to. And then I get a pointer to whatever comes after it, right? And if tail is equal to remove, then I'm going to modify the tail to point to temp. And otherwise, I'm going to set temp next equal to remove next. And then we delete remove. And those are the steps we talked about before. Actually, I think, you know, looking at this code, this shouldn't be else. I should just set temp next equal to remove next. However, there is an extra, there is a concern my code here has that, there is a case I should have pointed out to you. What if the iterator is pointing at the last node in the list? Then actually nothing comes after it. And I wouldn't want to try to remove something that isn't there. And so in my initial condition up here, this, if it's empty, or if my iterator is pointing at the tail of the list, there's nothing to do. Because there's nothing that comes after it, so there's nothing to remove. So in either of these cases, I actually bail out of this function earlier. Okay. So this removeAfter function, it's a fully general iterator-based remove operation. With it, we can remove any node in the list. All we need is an iterator to the node before the one we want to remove. It can remove the head, the tail, or anything in the middle. Because it's iterator-based, the client code that uses it doesn't need to understand how to update the list upon removal. We're able to pinpoint what we want to remove using the iterator, and then our object does the removal for us. Okay, we need a special case to remove the head because no node is before it. And so passing in a null pointer iterator is a useful trick for that purpose. A question I would ask you is, if I have an iterator and I use it to remove an object, can I use it again to remove another object? Or does that iterator become invalid? What do you think? Well, it turns out I can keep using it, right? I can keep using it as long as there's something after it. So I could stick an iterator at a specific point in the list and then just repeatedly call removeAfter to delete everything that comes after it. Since that iterator is fixed in a single point, I can keep using it to delete whatever comes next. And as I delete what's after it, the list after it's going to keep shrinking and shrinking and shrinking until there's nothing after it anymore. And then at that point, I could keep calling removeAfter. I wrote my code in a defensive way so that it won't fail, but there wouldn't be anything else. And it would just eventually removeAfter would just do nothing. It would just return silently without removing anything. Okay.